Okay friends, in this video we are going to see how to work out the flat belt problem. Okay, this is the given question. Flat belt 11A. It is required to select a flat belt drive for a running fan. Okay, flat belts. First we'll take the given data. So given like it is required to select a flat belt drive for a fan running at 360 rpm. Okay, it is given fan running at 360 rpm. Okay, we'll take that one as capital N 360 rpm, which is driven by a 10 kilowatt, that is power equal to 10 kilowatt. Then 1440 rpm motor, that is rpm, speed of the motor, right here, small n, 40 rpm. The belt drive is open type and space available for center distance is approximately 2 meter. Center distance 2 meter, that is 2000 mm. The diameter of the driven pulley is 1000 mm. Driven. This is the driven. This is the driven. Okay, then this is the capital D. 1000 mm. Okay. First we will write down the steps. We have the capital D, but we have to find the small d, and we don't have the I value. First we will find the I value over here. Okay, I equal to small n by capital N or capital D by small d. Okay, I will find the I value. Small n is 400 divided by 360, that is 400 divided by 360, that is 4. So the I value is like 4. We got the speed ratio, I value is equal to 4. Okay, or velocity ratio, anyway you can say. Now we should find the capital D if needed. We will find it now only. That is same formula, I equal to capital D by small d, that is 4 equal to 1000 by d. Then d equal to divide into, we should actually divide this one like 250 mm. Okay, got that small d 250 mm and the I value. Okay, then the first step will be material selection. Solution. From here the sum starts. First step will be material selection or weld selection. Okay, the first step will find the design power, that is dp. This you should this formula will not be in data book. You should memorize dp equal to load correction factor, okay, into a, that is load correction factor into of contact factor, that is P into load correction factor into angle correction factor. We know the P value, that is 10 kilowatt. We should find the load correction factor, that is K, that is load correction factor. Load correction factor can be found from page number 7.53. Okay, should take page number 7.53. In 7.53 you might find there's load correction factor. It is no, in the sum they are given as fan running, so we should take for fan. It's here for fans. Okay, so we will take 1.2 steady load. Okay, okay, fan running, so I'm taking like 1.2 load correction factor. Okay, 1.2. I got the load correction factor from page number 7.53. Now we are going to find the angle of contact. That is case angle of contact formula will be from page number 7.454. In the top you can find angle of correction 180 degree. That is the formula. Okay, 7.54. Write down formula on the next page. 0.54. The arc of contact, right? Arc of contact is theta equal to 180 degree minus capital D minus small d divided by C into 60. Okay, first the capital D we have, small d we have found, C value we have. Okay, we will substitute all the values over here. 180 minus, what is the capital D, you know, is 1000 minus 250, that is 750, divided by C value is 2000. As we can see, the C is 2 meter, 2000 I'm taking into 6. Calculate this one. Okay, 750 divided by 2000, 760, 180 minus answer. I got like 157.5. Already now 157.5. I got the theta value from the bottom table. For 157 we don't have 157, we have 160. The next value I'm taking, and the correction factor will be 1.08. okay, assume this as 160 degree and the correction factor is 1.08. that is, okay, this value is 1.08 correction factor value. Okay, we got the angle of correction factor value 1.08. Now we can substitute in the design power formula. dP equal to power, first the power value now 10 I think so. We are getting power is 10 kilowatt. I'm adding like 10 kilowatt into load correction factor is 1.2 into 1.08. And so it's 1.2, yeah, 1.2 into 1.08. okay, 10 into 1 into 1.08. I'm getting like 12.96. It's like 12.96. This is the design power value I'm getting, 12.96. okay, we'll keep this one and find the belt selection. Next step for belt selection, that is from page number, you can find in 7.52 in the top, you can find two belts. Okay, 0.52 in a sum they are given. It's a fan, so load correction factor is 1.2, so we can take this as a low duty or a medium duty. For low duty or medium duty, light or medium duty, we are going to take like this. Recommended for light and medium duty, and for high build speed, heavy duty. Okay, we will take this one, first one, that is high speed 878. Okay, or 4, we could choose anything. We will choose the first one, high speed 878 G fabric. Okay, before selecting the build speed, build selection, we'll find out the velocity value. 2 pi dn by 16, you'll see which one. Then we have got over here, so always go with the smaller pulley. We got pi d, we don't have, okay, we have the formula substitute over here, that is pi, and the small d is like 250, and the n value 1440 divided by 60. It's like this, the velocity value that we got is 18.84 into 10 to the power of 3. Actually it's lesser than 20, so we are going into the high speed belt. Okay, lock high speed belt right here, low high speed belt, we are going for that belt. It's on AG from page number 7.52. okay, from this is a belt. Okay, the next value we are going to find that is belt rating. We should find the belt rating. Next step, find the belt rating formula will be in page number 7.54. in the top you can find like for high speed we have taken the high speed, right? So for high speed 878 clean G belting, we have got the power value in kilowatt, so we are going to take the first one, 0.023 kilowatt per mm per ply. We'll write down the formula over here. Okay, we'll write down over here, that is for high speed rating 0.023 kilowatt per mm per ply. Okay, that is, they are saying like per mm per ply. For you can find over here for 180-degree arc at 10 meter per second belt speed, they are given this formula. So we are going to take it like for 180-degree, and for 10 meter we have got, instead of 180 we got like we got like 160. So we are going to write down 160, and instead of 10 we got the velocity as 18.84. 18.84. Per ply, we should now find the number of plies value. Over here we don't know, it's an unknown value. Just a minute. Okay, I'm going to find the number of ply value. How should find the number of plies? I'll show you. Number of plies you can find from page number you can find it from page number 7.52. In the bottom table you can find the number of plies according to the bell speed and the diameter. Bell speed we got is like 18.84. So we are going to take like 18, we'll go with 20, and they ask for minimum pulley diameter, so that's the small d. 20, we got like 250. Okay, 20, 250, and the number of plies is 5. Okay, number of plies equal to 5. Now we will substitute in this formula, previous formula we got, so it's like 0.023 into number of plies into 160 by 180 into 18.84 divided by 10. So we'll see what we get. 60 80 into 5 into 0. We got like 0.19 number of 0.192. This is the belt rating. We got like BR value. Okay, 0.192, and forgive me, sorry. Okay, now we are going into the, we have got the belt rating. I think we should standard the belt rating value. We have got the belt rating value. Okay, belt width, we are going to find the belt width value, the next step. Before that, I think we should find belt width. Belt width formulas dp by bar, that is design power. We got like 12.96 divided by belt rating 0.192. It's like 12.96 divided by answer, you get 67.29. And this is the belt width we got. Okay, we are going to standardize the belt width, that is 67.29 from this standard width table from page number 7.50. That is 7.52. We got 67.29. We have gone with 5 number of plies. For 67 we don't have 67 5 plies, so we are directly taking 76. Okay, take 76. That is standardized value is 76 for belt width. Okay, we have got the standardized value for belt width. Okay, next up, this last step, we are going to find the length of the belt from page number 7.53. In 7.53 in the top you will have the length value, that is for open dry. First one we chose, that's given in the question, length equal to c plus pi by 2 capital D plus small d plus capital D minus small d the whole square divided by 4c. That is like, substitute here, like 2 into c is 2000 plus pi by 2. They are asking 1000 plus 250, 1250 plus 750 the whole square divided by 4 into 8, that is 8000. Now we'll substitute all the value, the calci, that is like pi divided by 2 to 1250 1000 plus 963.195 50 the whole square divided by 8000, that is 70.3125. Answer plus 5 plus 4000. I get this the answer 60, that is 6033.80 mm. This is the length of the belt I'm getting. Okay, next we have to find the belt. We should belt standardize. We should due to the slip we should reduce some of the length value in belt. So for that we are going to take police to be wider than belt width by okay, belt width going to be thinner, that is like some amount of, or else you don't need, you can leave that one. Maybe you can give belt tension. They are given belt tension, that is like belt of 4 5 6 plies 1% or 10 mm per meter shorter. They are given like for say 5 plies 1% or 10 mm shorter, that's like 10 mm shorter for 1 meter they are given. Here we have 6.3 meter and 6.3, that's like 6.3 minus this 10 mm minus 10. This is the length value we have got 6023. So we have got like after shortening 6023.8. After shortening, this is the length value we have got. Now we are going to find the pulley width. Okay, pulley width. pulley width. In page number 7.54 you can find the pulley width, that is like we got 60 up to including 125 mm. That is the belt width we have got left. We'll see what the belt width we have got is 76 belt width. So up to 76, that is first one. Out to 125 mm we have got pulleys to be wider, belt width by 13. Pulleys to be wider than the belt width, that is belt width is like 76 plus wider 13 mm, then it should be 89. See, 89 it should be 89. This is the pulley width we have got is 89. After this we have on the last step we will form the crowning of pulley. Okay, there should be some crowning in the pulley like over here for to reduce the slip the belt. So we are going to here in page number 7.55 in the top you can find this table. In the top you can find this table for the crowning of pulley. That's capital D. We have got the capital D as 1000 mm, that is more than 355. So we are going to move 1 mm for 355. So for 1000, like we are going to take like 2 or 2.5. We'll take like 2.5 or 2. So crowning is 2 mm. Okay, just the sum is finished. Okay, in flat belts, simple. I'll show you the steps what we have done. In flat belt, first we are going to write down the given data from the question we have got, that is the capital N, that is the fan or the something, and the which is the smaller pinion, small n speed, and the power, and the center distance, and the diameter we have got, and the I value, that is speed ratio or velocity ratio. I value is like small n by capital M or capital D by small d, and we are going to substitute and we are going to find the I value equal to 4. In this we are going to find out the small d value by substituting over here. Small d should be smaller than the capital D value, so I got like 250 mm. And the next step, descent power, first step we are going to calculate the descent power. We should memorize this formula: dp equal to power into k into k, that is power into load correction factor into angle of contact factor, and load correction factor is from 7.53 we should find, whereas in 7.53 we'll find over in this table, that is for load classifications like given, and from question you should know what is the load, and this one we have given fan, so we have took like 1.2 load correction factor K value, and the next is angle correction factor, that is 7.54. In the next page you will find the angle correction factor in the top. This is the formula for the angle correction, angle of contact. We should substitute the values are here and we will get a degree like 157.5. so for 157, below table you are given the angle of contact. I don't have 157, so I'm taking as 160. For 160 I got like 1.08. so this is the 1.08 is the angle of contact factor, and I'm going to substitute in design power value, power into load correction factor into angle of contact. I get like 12.96. and the next step, belt selection, is from 7.52, that is from over here. The 7.52 we have belt selection, 2 types of belts. For that we should map the velocity formula and find the speed of the belts. It comes under 20, so I'm taking like Dunlop high speed, the first belt. If it's lesser than 20, and if it's higher, we are going for the second one. I have taken the first one in this. I am to note down the belts. name high speed belt 87G Dunlop. Okay, then next step we are going to find the belt rating from page number 7.54. That's like belt rating we have got over here. There is high speed 878 duct belt rating, that is we have got the power value in kilowatts, so we are going to take the first one 0.023 kilowatt per mm per ply. For this is substituted as per 10 meter velocity and 180-degree arc of contact. So we are going to take for our value like 0.03 the same number of plies once, so we are going to put 180 by 10, and we are going to substitute our get a calculated value like 160 into our velocity 18.84. In this step we have to find the number of plies. Number of plies can be found by 7.52 with the page 7.52 with respect to the belt speed and the minimum pulley diameter we could find. That's like belt speed I got like 18.84, so I'm getting like 20. I have taken 20 and our diameter is 250, so we have got like number of plies 5. I have noted down the 5 number of plies, and I have got the number of, I'm going to substitute the number of plies in belt rating formula. I'm getting the belt rating as 0.192. In the next step I'm finding the belt width, that is from 7.52 belt width. Okay, first we have to find this is the formula we should memorize, like belt width equal to descent power by belt rating dp by br. Descent power we got in the previous step 12.96, and the br is 0.192 we have found. We have got like 67.29. We are going to standardize this value from page number 7.52. In 7.52 you can find the middle table. We are going to middle for 5 plies, that is like 5 plies. I have got like 67.29, so the first value I'm going to take like 76. This is the starting value 76. I'm not down the standard value 76. And the last step we are going to find the length of the belt, that is given in the 7.53 page number. In the 7.53 page number in the top you could find the length formula for open drive, L equal to 2c pi by 2 capital D plus small d capital D minus small d the whole square divided by 4c. I'm going to note down the formula over here and substitute all the values, so I'll get an answer like the length is like 6 meter, that is 66,000 mm, that is 6 meter. Okay, now the next step I'm going to make like we should shorten the belt for the tension. In the next, in the bottom you will find like for belt of 4, 5, 6 plies we have to like 1% or 10 mm per length is shorter, that is I'll take like 10 mm. For this is like it's like 60,000 mm minus 10 if you do it's like minus 10 if you make it for 60,000 mm you're like 6023.8. This is the length, shortening length value after tension. In the next step you have to find the pulley width, that is like pulley width you should you will get from page number 7 point, tell you. Okay, it's like in 7.54. I should have noted. It's like in 7.54 you will get the pulley width formula. In pulley width 7.54 you would have a table over here, that is the belt width up to including belt with respect to belt width. Belt width we got like after standard value we got like 76. Over here we are going to take belt width, that is 76, that is up to 125. This to be plus 13 mm, should be pulleys to be wider than the belt width by 13 mm. So I took like belt width is 76 plus 13 mm, we got like 89. This is the pulley width value. And last step we are going to do the crowning of the pulley for the slip for reducing the slip of the belts from the pulley. Okay, crowning of pulley is from 7.55. In 7.55 there's a small table over here, a crown of pulley with respect to the capital D. Okay, diameter we got the capital D in the sum is like 1000 mm. So I'm going with the last value over here 355, that is given as 1 mm for the crown. So I'm going to increase it by another 1, so it's like crowning is like 2 mm. This will reduce the slip of the belts from the pulley. Okay, and here our sum is over. What they have asked in question is to the diameter of the pulley. It's okay to select a flat bolt drive for okay, we are selecting a flat bolt drive and we have got the answer, and that's all. Thank you.